Here's the simplest way to make agents safer without pretending the prompt injection is solved, because it's certainly not. The simplest answer is don't give one AI all the keys. If you have a single agent that can read data, take irreversible actions, or communicate externally, that's not an agent. That's an exfiltration machine waiting for a clever prompt. Listen, security isn't about whether a model is good or not. Security is about what happens when it's wrong. So the question you need to be asking yourself is, what's the maximum blast radius when something does go wrong? Because it will. There's a pattern that's showing up again and again in real incidents. It's a high-risk combination of these three things. The agent processes untrusted data. The agent can access sensitive and untrusted data. And the agent can change state or send information out. If you put all three of these in the same place, you've effectively asked a model to be your security boundary. And models were never meant to be security boundaries. They don't know what's supposed to be trusted. They don't know the difference between your policy doc and an attacker's document. All they see are just tokens. Listen, your board or your leadership doesn't care about jailbreaks. They don't need to see the jailbreaks. But they may ask things like, what powers have we combined into a single agent? Where in the workflow are we requiring approvals? And what's the maximum damage from one compromised session? And to me, that's a much better conversation than is the model safe? Let's take a look at a very common pattern. You built a research agent. It has the ability to read docs or scrape the web. Let's say in version A, it's mostly read only. The maximum risk here are hallucinations or incorrect summarizations. While maybe embarrassing, it's not really an incident. Maybe now you add a new tool to that or a new webhook. Now you add the capability to outbound calls, maybe send emails. Now your agent isn't just reading, it's communicating. It's that two-way communication that causes the most risk. And suddenly any indirect prompt injection from a web page, from a PDF, can steer the output of that model, even if you filter prompts, even if you check for model safety. It's that combination and the stacking that becomes the issue here. So the rule of two is a practical forcing function. It's a really simple idea. The agent that reads a lot shouldn't be able to do a lot. And to put that differently, it's separating understanding from acting. So here's a concrete pattern that implements least authority without really impacting velocity. We've noticed a lot of these in computer science over the years as different programming patterns. Think of these patterns in a similar manner. We have a reader or a planner versus the executor split. So the reader can browse the web or look at data, but it's not really a high impact tool. It could just fetch information and digest it and summarize it. But it produces structured output or structured plans. Whereas the executor has the tools. It's able to take that output and do things with it. But it operates in a very narrow scope with a very intended input and output destination. This turns a messy injection-prone context window into a constrained interface. Scoped credentials, not omnipotent key. We don't want long-lived API tokens that reside in the model context. Instead, we want short-lived, aggressively rotated keys that are incredibly narrowly scoped. We should just treat these credentials like any other production credentials because that's basically what they are. Maybe like an egress allow list. Like if an agent shouldn't talk on this particular part of the network, you should not allow it to. Don't give attackers the option to explore what you haven't constrained. Instead, allow listings. Allow it to access a certain endpoint. Allow it to access a certain data store. Implement some high impact gating for things that are like production configuration changes or any kind of external communication or any kind of access granting. Require a human in the loop to allow the agent to work in those actions. One of the best mental models for this is interns could read documents. Executives write the check. Don't combine those roles into one process. And again, very common in computer science, start implementing circuit breaking. Even with gating that we just talked about, things can go weird. So this way you can now rate limit side effects with circuit breaking. You could stop novel domains or you could stop repeated attempts at things. This way we could stop things like anomalous tool patterns before they make a large production impact. People are going to hear this and immediately say, hey, but that reduces autonomy. Yes, it does. And that's my point. Security really is the art of choosing where you can afford autonomy and where you can't. Listen, if you need full autonomy everywhere, you're not asking for an assistant. You're asking for a brand new, completely privileged user where the attack surface is now just natural language. Listen, if you do nothing else with agents, do least authority. Yes, it's boring, but it's also really effective. My name is David Campbell. I talk about AI security and AI risk. Tune into the next episode where we're going to talk about rag poisoning. so we can understand how your knowledge base can now become an attack surface.